Riders of powered two-wheelers are more vulnerable than occupants of other motorised vehicles such as passenger cars. As a result, they are overrepresented in the European road casualty population. One of the aims of the European Commission is to reduce casualty on Europe's roads, and the EC has jointly funded this project together with various other partners and sponsors. The project is called PISA, Powered Two-Wheeler Integrated Safety. By powered two-wheelers, let's call them PTWs, we mean motorcycles, scooters, mopeds and electric bicycles, sometimes called mofas. The aim of the PISA project was to develop an integrated safety system that would contribute to the avoidance of a crash or a reduction in injuries resulting from a crash. The PISA approach included a review of PTW crash statistics. The crashes that were most frequent and most important in terms of injury were identified. In-depth crash data was examined. For each case, a decision was made about what would have avoided the crash, avoided the injury, or reduced the injury. PISA only considered technical solutions that were relevant to the PTW and not to other road users and vehicles. The idea was to explore the possibilities and to demonstrate how these might work on a PTW. This initial concept may go some way to achieving a technical solution, but further development and evaluation will still be necessary. The philosophy of the PISA system is to support the rider in safety-critical situations. This video gives a visual representation of the systems in action, but actual crashes are not shown. The PISA system is a smart speed reduction system made up of two separate subsystems, active braking and distance support. This system has been demonstrated on a Malaguti scooter. The PISA project also assessed a combined braking system and an anti-dive suspension system. This system has been tested and developed on a TVS motorcycle. We'll look at that later, but first let's look at the Malaguti scooter. A common crash situation for powered two-wheelers occurs at intersections where another vehicle moves across the path of the PTW. This scenario is the most significant in terms of the number of crashes and the severity of injuries to riders of both mopeds and motorcycles in urban and rural locations. The PISA system incorporates active braking, which is activated when the scooter is on collision course with another vehicle. This may be a slower moving or stopped vehicle or another vehicle crossing the scooter's path. The system will activate at the point when a collision with the other vehicle is unavoidable. It will not activate if the scooter is leaning more than 10 degrees or travelling at less than 5 kilometers per hour. The benefit of the system is to alert the rider to this inevitable event and to automatically reduce the speed of the PTW. The key components are a laser scanner, control logic, vibrating seat, anti-dive suspension and braking system. The laser scanner constantly detects objects or vehicles in the PTW path. The control logic then uses this information to calculate the path of the other vehicle. If it calculates that the paths of the vehicles will cross and a collision is inevitable, it will activate the system. There's also a vibrating component fitted in the seat which warns the rider when the brakes are about to be applied automatically. The anti-dive suspension increases fork stiffness in order to reduce front-end dive when the brakes are applied. If the rider applies the brakes once the active braking system has been activated, then additional braking is applied to the front brake by the enhanced braking system. The front forks are also increased in stiffness. So those are the components of the PISA system. Now let's see how they work in practice. First we'll see the scooter approach an intersection. As the scooter travels along the road, the laser scanner is constantly monitoring the scene ahead. As the car approaches the intersection, the laser scanner will detect it. When the control logic calculates that the car will cross the path of the scooter and a collision will be inevitable, then the active braking system is activated.